If I'm circling the angle theta, what side is that? It's the opposite, therefore this is the adjacent. Now, again, if I was up here, my opposite would have been on the other side. So remember, trigonometry is nothing more than the perspective of the angle that you're sitting at. So from these things, you guys all remember your three trig functions, right? Sine, cosine. All right. Now, I'm writing this now in terms of theta. You guys have seen it in terms of x, angle A, angle B, whatever. I'm just going to use this symbol for theta, okay? Sine is what over what?
Opposite over.
Good. So the sine is your opposite over hypotenuse. Cosine. Okay. And lastly, tangent. Good. And again, this is one of those things that you guys all remember, the good old-fashioned SOHCAHTOA. Right?
Yeah.
Okay.
We should say yes.
Now, I am going to introduce you guys now to their inverses. There are three trig functions, and there will be three trig inverses. Cosecant, secant, and cotangent. Have you guys heard of those?
Yes.
These are the inverse trig functions. Cosecant of theta, secant theta, and cotangent. Now, when we're talking about inverses, think about it in terms of a fraction. When you talk, what's the inverse of 2/3? 3/2, right? What did you do? You flip it. So cosecant is nothing more than the inverse of sine. So cosecant is hypotenuse over opposite. Secant. It's okay. Okay. Now, to be honest with you, in this first section, we're dealing with working with the trig functions themselves. You're not so much going to be writing out what you're not going to be solving for the cosecant of the angle. A lot of times, what will happen is they might give you cosecant of theta is 7/3. Well, that means in a right triangle, the hypotenuse is 7 and the opposite is 3. That's basically what you're going to be using this for right now. Eventually, when we start working with these inverse properties, there's a lot of other things that we're going to be able to do with that. And that's mainly going to get more involved when we get into chapter 14. Just want to get you guys into the groundwork of the verbiage. Okay? I'm glad you got your phone back, but come on. Special right triangles. Remember these?
No.
Isn't it like
No, we ma'am.
We have the 30, 60, 90s. We have, good. So when we're dealing with the special right triangles, we've got our 45, 45, 90.
Those were ours. That was 45, 45, 90.
Now, when you're dealing with those, you guys remember the ratios of sides? All right, so it's x, x, and then what's the last one?
Root 2.
X root 2. Good. And what I'm going to do here in a second to show you guys how this works, there's going to be a generic way of writing these out here in a second. Okay. Now, with the 30, 60, 90, in a 30, 60, 90, again, I always set up this little algebra jig here, and I'll explain what this looks like. What was it again?
X, 2x, and
It was x, 2x, and x root 3. Which one gets the x root 3? The 90? Now, if 90 had a root 3 across from it, and that means the 60 would have a 2. What number is bigger, 2 or the square root of 3? So that means 2 would have to be here, right? You guys remember that trick when you're dealing with angles and their sides opposite them? The smallest angle generally has will always have the shortest side length. Largest angle have the largest side length, and so on. If they're the same angle, they have the same sides. Go figure. It's crazy how math works. So what happens now, as opposed to what you guys have seen in the past, is just a little bit different from the way that we've worked these things out. The 30, 60, 90 and the 45, 45, 90 triangles are going to be basically the basics, bless you, of the second half of chapter 13, all of chapter 14. These trig functions, you're going to want to know what the sines and cosines and tangents are of all of your special right triangles. Let me show you how you work through this. What happens here, if I'm looking at a 45, 45, 90. We said the sides were the pattern of x, x, and the x root 2, correct? Let's let x equal 1. So it would be 1, 1, and square root of 2. Do you agree? Okay. So let's do this. What is the sine of 45? You don't need a calculator. Sine is what over what? 1 over root 2. Do we like radicals in the denominator? No, we don't. How do we rationalize that? So you get root 2 over 2. Does everybody agree? Yeah. Okay. What is the cosine of 45? When you rationalize, remember you're multiplying top and bottom by the square root of 2. Square root of 2 times square root of 2 is 2. All right. Isn't the cosine of 45 also going to be the same thing? Yes. Okay. So we know it's root 2 over 2. Now let me ask you this. Do we ever take tangent sines or cosines of 90? Why? Okay, if I wanted to do the sine of 90 degrees, the opposite and the hypotenuse are the same angle, correct? Because the opposite u is the hypotenuse, and the hypotenuse is the hypotenuse. Now, what would be the cosine?
Yes.
No, because you don't know what the adjacent is to 90 degrees, do you? So what happens here is we never worry about your trig functions at 90 degrees. This becomes more apparent when we get into working with the unit circle in 13, I think it's 4. I don't remember which one, but when we talk a little bit more about that, I'll define to you guys why it doesn't work. Okay? And then lastly, what's the tangent of 45? 1. Okay? So those are your 3 trig functions. What would be the inverses? If the
2 over, oh my gosh.
oops,
1 over root 2.
let's do this. So with the 45, we said it was 1 over root 2, which became root 2 over 2. This is root 2 over 2. This was 1. Aren't the inverses just flipping the fractions?
Yeah.
Okay. So if the original was 1 over root 2, what would be the inverse of that? Just root 2 over 1. Wouldn't that be also the same thing for the secant?
Yep.
And what would be the inverse of 1?
I don't know.
Again, what we're looking at being able to do here, guys, is I just want you to define out what is it going to look like when you flip fractions. Okay? Let's look at the 30 and the 60 real quick. When I'm looking at the 30 and the 60, again, I'm going to use 1, 2, and root 3. Is that all right? Okay. If this is my 30-degree angle up here, that makes this one the 60. The sine of 30 is what over what? So it is 1/2. What would the cosecant be then? Cosecant. 2. The cosine of 30 is how much?
Root 3 over
You just want to say what the next one is in order. I'm jumbling it up on you to make you think. You get root 3 over 2. Everybody agree?
Yeah.
All right. What about tangent?
1 over
1 over root 3, which becomes
root 3.
root 3 over 3. Very good. Okay. Now, cosines. Not cosines, excuse me. Sines of 60. Cosine of 60. And tangent of 60. What would the sine of 60 be? Root 3 over 2. Cosine? Is 1/2. And then tangent.
Root 3.
Root 3. Okay. Now, again, when we worry about the inverse of these, it's just nothing more than flipping the fraction each time around. Okay? Do I need to do that? So if I wanted you guys to write out the, if I wanted you to write out, let's see, a if I want you to write out the 6 trig functions for angle B.
Sine, cosine, tan, and then inverses.
Yeah, then the inverses. Am I asking you to solve for the angles here?
No.
Am I asking you to just write out ratios of sides? Okay. What's the first thing you got to figure out?
What AC is.
What's AC?
It's 5.
No.
Twelve.
What is something you can do?
It's 12.
It's 12. If it's a triple, if you remembered it's a triple, it's okay. If you didn't remember the triples, shame on you, shame on you. But, so,
I don't know. That's such a weird one. I never 12, 13, 5.
if you forgot it, I mean, what could you always do though? Pythagorean theorem?
Oh, yeah.
Oh, that's right.
Oh yeah, duh.
I remember because 3 is, 1 plus 2 is 3, and then 1 plus 3 is 4. You got another triple.
I forgot how to
Sure.
Yeah, A cube plus B
Yes.
cube equals C cube.
So, the sine of B is what over what? Okay, cosine of B.
12 13s.
5 over 13.
Tangent.
This is 5.
This colorful kind really comes in handy sometimes.
Now, when we talk about writing out the inverses, again, when you're doing an inverse, you just flip the fractions, guys. So, cosecant of B, 13 over 12. Bless you.
Thank you.
Secant,
13 over 5. Yeah.
and then cotangent. Hey, bless you. All right. Again, what we're looking at here, guys, is a lot of review. All right. Lots and lots of review. So let's take it a step further. When we take it a step further, we're going to start solving right triangles. And when we solve right triangles, it means we got to find how many parts. Well, how many parts are in a right triangle? 6. There are 3 angles and 3 sides. Do you agree?
Yeah.
Okay. Now, one of those things you're going to know right away because it's a right triangle.
True. 90 degrees.
You know you have a 90-degree angle. Do you agree? All right, so that means how many things you have to start figuring out. 5. Okay, why not?
5.
So I know I've got a 20 degree here. I've got 12 here. If I need to solve for all the other parts, one of the easy things to do is just label out what you got to find. Remember, they'll help you remember what you got to find. Now, in this case here, what's the easiest thing to find first? What's the other angle? The other angle is 70. Okay. Now, here's my little take on this. Let's say you figured out the other angle, but you accidentally wrote 60. If I then use that 60-degree angle to solve for the other sides, I'm done. What I want you guys to do here, when you're given these parts, I'd like you to start reusing your givens. What that allows you to be able to do is, if you make a bonehead move and accidentally write down the wrong number, and you reuse that, you're never going to get the right answer. But if you reuse your givens, you still have the possibility of getting something correct the second time around. So, when I set these problems up, I always circle where I'm starting with. I identify my parts of the triangle. Well, this is my opposite. I know this is my hypotenuse, because it's across from the right angle, which gives me the adjacent. So, in order to solve for the adjacent, knowing the hypotenuse and the angle, what trig function? Tangent.
Wait,
Sorry, Mike said it this time.
the other Mike said it. First time, actually. Wait, what? Did you flip your pencil?
No, I just went like this and it fell out of my hand and it flying.
Sometimes when I grab my pen, I like flip it on accident. No one goes flying.
Yeah, me too.
That's just because you were throwing it at him, right? I'd like to.
Because I grab it and then, I don't know, it's so weird.
It happens to everybody, Mike. Don't worry about it.
Alright, cool.
Like, hi.
Everybody agree it's going to look like that?
Yeah.
Okay. Do you remember the trick whenever your variable is in the denominator when you have to solve this?
You multiply.
Said I.
You just flip flop them.
Okay, go low.
Is it flip
Top,
top?
said I.
top.
Says
Hey guys,
Right the top like that.
again, at this part here, when your unknown is in the denominator, all you have to do is just flip. You just replace it. B is 12 over the tangent is 20. Just a reminder, make sure your calculators are in degree mode.
How do you do that?
Press the button that says mode, and make sure it's highlighted with degrees.
Mode. That's normal.
Oh, mine wasn't.
All right. Most of these things default to radians.
Where should we be?
Hit mode, and you want to make sure it's highlighted under degree.
Oh,
Bless you.
green. What's the difference?
What's that?
What's the difference?
Radians are dealt with terms of pi, and when we get into the unit circle over the next couple of weeks,
So, Mike,
for example, this is 90 degrees, right? This is 180. This would be 360 going all the way around. To go all the way around the circle is 2 pi. Okay? Which means at 180 it's pi, and at 90 it'd be pi over 2. You okay with that? What's halfway between 90 and 0?
45.
So what's half of a half?
Fourth.
So this at 45 degrees is pi over 4. So if you're in radian mode, we're going to be dealing with things in terms of pi. There's a conversion to be able to do all of that, and it is very, very simple. Yes, sir?
So if that's, would that be 2 pi and 0? 2 pi?
They are coterminal.
Alright.
You have to start somewhere. Do you agree?
Oh yeah.
You start at 0 and you make one. Here, stand up.
Alright.
Spin 360 degrees. You wound up where you started, right?
That's true.
Your spin allowed you to wind up in a coterminal place.
So 0 is.
Let's just English. Let's just
0 is 0.
disagree and continue.
Right. So
Anyway.
it's all about time.
It's space. Anyway,
What are we? What is our purpose
That's
here on
really
this
quick.
planet? There is no.
wow, look at that. So make sure for these first few first few sections, if you're getting very weird numbers, well, a lot of these are gonna be weird, but if you want to get like a negative value or something like that, or if your calculator falls, the batteries fall out, some along those lines, make sure you go back into degree mode when you're dealing with these sines and cosines today. When we get to the unit circle, then you will definitely know that the calculator basically doesn't do anything for you anymore. You kind of have to crank out a lot of that by hand. All right. Now, if I wanted to find the hypotenuse, what trig function am I going to do when I have the opposite and I want to find the hypotenuse?
Sine.
I'm going to do the sine. Very good. So the sine of the angle.
We should have killed that.
No. Again, please do me a favor when you're writing these things out. I know these first few sections, it's all calculator work, guys. But if you're typing in the wrong things, you're going to get the wrong answers. But yet, if you write down what you're about to type in the calculator, I know if you just typed in something incorrectly, or if you don't know what you're doing. So please, before you type in 12 divided by the tangent of 20 in your calculator, please write down that's what you're about to do. So that way, if you happen to accidentally type in 13 divided by the tangent of 20, I know that you just pressed the wrong button, but you still got the right answer. Does that make sense?
Yeah.
It happened on the test. There were a couple of instances where people had the exact correct result of before you wrote it into the calculator, but typed in something incorrectly, and I gave it to them because they knew what they were doing. Okay. Make sure you show your work on a lot of this stuff. It only takes a second. Like I said, you guys have done this material before. This is not a lot of new material for the first day. Also, I wanted to redefine angles of elevation and angles of depression.
I was gone for this.
Yeah, I remember that.
So,
You just lose like sick or something.
Yeah.
Yeah, I remember because class sucked. Oh, I'm depressed.
what are those?
Those are
They're parallel lines, okay? Now, what happens when you have parallel lines, if you have two parallel lines cut by a transversal,
Oh, I cannot remember like these terms.
But they're still.
This is sad.
so what happens here,
Don't make that.
the angle at which from ground level looking up is considered your angle of elevation. No. I'm just defining where it comes from. The reason that these two guys are the same angle is because what angle pair relationship are they?
Interior.
Parallel.
Opposite
Parallel interior 90 degree.
Postulate. Arrow
If two parallel lines are cut by a transversal, opposite interior angles are congruent. This is your horizontal line looking downward. This is your angle of depression. What happens here is that your angles of depression and your angles of elevation are the same. What'll happen though is that it'll be given to you within context of a problem. For example, you have an airplane.
It's horrible. That is horrible. Don't ever make that joke again.
Okay?
It looks too short.
You have an airplane, and you have the tower.
It looks like a little like.
That's Shamu from Blackfish.
And you want to avoid leaving the tower.
Yeah, it does look like a shark.
There's the door to get in, and there's the runway.
You are a great artist.
I'm horrible, I know.
Gas.
Wait, what is that?
It
looks like plankton. Oh. It's the like control tower.
Terrible, I know.
Control.
Why is
The plane is above.
You're 37,000 feet up in the air.
Not a good day.
Good chance.
That building must be really tall then.
It's not to scale.
No.
I'll make this better.
Hey,
All right. Now I am absolved of all of my drawing sins. Okay.
Like 10,000.
Let's say the angle of depression. The angle of depression from the airplane to the tower, the base of the tower. Exactly, it's the same problem. The angle of depression, let's say it is,
In the shadow.
I don't know, 17 degrees. How far away is the base of the tower
To the ground.
to the vertical height of the airplane?
That's a
It's
good
a some
question.
number.
Some number, yes. Remember,
Tangent
Wait,
something.
what is it, 17 degrees?
That number
Yeah.
over.
37 over X.
37,000 over X. or
Yeah.
whatever.
what happens here, guys, is when you're doing these types of problems, remembering that angles of depression are congruent to angles of elevation. A lot of times you're going to redraw it to come inside of the actual right triangle. Use that as your 17 degree. There's your right angle. And if you have to solve for this horizontal distance, you're right. You were saying it was tangent.
So it's just like a little bit.
More often than not, when you're dealing with an elevation or depression problem, you're using tangent.
It
Right.
seems so much easier now than it did last.
Yeah, it always, I mean,
I don't know,
does.
I feel like it is.
Please. Oh my God, fruits.
and again, all you have to do is divide out by the tangent of 17, and what did you guys get from the horizontal distance?
Big crazy number.
X equals 37,000.
1, 2, 1, 0, 2, 1, 5, 4, 6, 9.
101,
No, 1,
whatever, some number.
It starts with a 1.
Anyway, you get the idea, right? Now, the other part of this stuff then,
What is that?
I was going to do elevation. He was going to throw something at the clock.
Oh, you should do that.
Wait, when are you going to do your bow and arrow?
Bow and arrow? Oh, you'll get there.
I thought we were doing it already.
How do you know about the bow and arrow?
Because you've told us.
Oh, yeah, I have. All right.
We're psychic.
What chapter is that? This chapter.
It's not this one. Real fast, go ahead and solve that one out, and I think I'll probably just give you some problems.
DHS props.
I think the last little thing that I wanted to show you guys with this stuff, in case you had forgotten some of it, is when you're dealing with your special right triangles. When you're dealing with the special right triangle, and let's say you're given this, and you got to find the other side of this. When I did these problems in geometry with some of you guys last year, we always set up the same thing. And it's a little bit different than what Sever or Ms. Hoff might have done. What I did here is that in a 45, 45, 90, you have this little algebraic jig, if you will. Now what I mean by the jig is that if you've ever cut banisters or you had to recut the same section of like deck wood or something like that, a lot of times, what you do is you set up a little jig that you just can use to help cut it quicker. It's the same idea when I'm dealing with this with an algebra problem. Every single one of these types of problems is the same. It's just a matter of which one you know. I know, for example, here across from the 90 is 10.
Yes.
So I have a one-step algebra problem to solve. X is going to equal 10 divided by the square root of 2. That means you have to remember how to simplify that. Do you remember what the shortcut was? We'd have to rationalize, you agree? When I rationalize it, I get root 2 over root 2. So I get 10 root 2 over 2, which is, and that's equal to my value of x. So this 5 root 2 will go here and there.
Wasn't there a shortcut to this?
There is. Cut it in half and slap a root 2 next to it.
Yeah.
Seriously. If it's 100,
No, you cannot.
what are the other sides? 50 root 2. If it is 9, what are the other sides?
4.5 root 2.
4.5 root 2. We okay?
Yeah.
All right. Now, the other one, there's a shortcut for the other one as well. In a 30, 60, 90. If I'm working with a 30, 60, 90, and I know across from the 60, for example, let's say across from the 60 is 12. To find the other two sides, again, you set it up in that little algebra jig, if you will. This has to equal 12, which means I have to rationalize. When I rationalize that, I multiply top and bottom by what? 3. You get 4 root 3. Do you remember the shortcut for that?
Divide it into thirds and slap a root.
Yeah. Cut it in thirds and slap a root 3 next to it. Okay. And that will always find you the value of x. So if that means across from the 30 would be 4 root 3. What would be across from the 90 then? 8 root 3, very good. Just trying to see if you guys remembered some of the shortcuts and go from there. So let me give you guys a few of these to try out. And we'll go to law of sines tomorrow. This is on page 772. All right. Do those, please. And that picks them